This is part 2 of section 3.2. Now we have some basic properties of logarithms. For any base a that's larger than 0 and a is not equal to 1, those were requirements for any logarithm earlier, it was in the definition. Log base a of a is equal to 1. Now if we convert that to exponential form, you'll see that if you convert this, you end up with a is equal to a to the first power, which you know is true. Log base a of 1 is equal to 0. If you convert this to exponential form, you'll see that 1 is equal to a to the 0. And you know anything to the 0 power is 1, so that makes sense. And now these two are based on the fact that logarithms and exponentials are inverses of each other. So as long as your base of your logarithm and the base of your exponential, on both of these that happens. If you have an exponential raised to a log with the same base, or if you have a log of an exponential with the same base, then you simply get x back. Okay? So let's use these properties to evaluate each of these. Log base 5 of 1. Log base anything of 1 is equal to 0. So that's 0. Log base 3 of 3 to the 5th power. We have this case here where we have a base 3 on our log and a base 3 on the exponential. So our answer is x. This is simply 5. And then we have 7 raised to the log base 7 of 5. This time we have case 4. We have a 7 here and a 7 here, so our a's match. So our answer should just be x, and this one is also equal to 5. Okay. Now because exponential functions and logarithmic functions are inverses, their domains and ranges are reversed. Now, so an exponential had a domain of all real numbers, and we would only get positive answers back. So for a logarithm, the argument, which is our x value, has to be positive. We can only plug in numbers greater than 0. We're not allowed to plug in 0 itself. And we will get any possible answer back. So our range can be anything, our y values can be anything, but our domain is, they are positives. Okay, so let's work a problem here where we are asked to find the domain of the following. We're not asked to do anything else, just find the domain. Now what we just said was that the argument of our logarithm, so everything you're trying to take the log of, has to be greater than 0. So what I need to calculate here is 2 minus x greater than 0. Not greater than or equal to, because the domain is has a parenthesis here. Okay? So solve this, and I have 2 is greater than 0. They will want your answer in interval notation, so this would be negative, not 0, x. So I'd have negative infinity up to 2 with parentheses. So I can plug in any number in this region for x, and I would have a valid statement. Here, f of x is equal to log base 10 of the square root of 1 minus x. Now, all of this is considered your argument, and so we want to find the domain of it. And I have two issues here. Before this section, we only had to worry about dividing by 0 and taking the square root of a negative number. I have to make sure that the number I plug in for x is not going to give me a negative number to take the square root of. And I have to make sure that this entire thing is greater than 0. So starting off, I I need the square root of 1 minus x to be greater than 0, because the entire argument has to be strictly greater than. Well, if you think about what we know about square roots, you're going to get a positive answer every time what is inside here is positive. So I can simplify this statement to 1 minus x is greater than 0. And this is also going to take care of the domain of this. The domain of the square root itself, you would be allowed to equal 0. But since this whole thing has to be greater than 0, we don't bring the equal to along here. We want the most restrictive domain possible. So solving this, we get 1 is greater than x. So in interval notation, this domain would be negative infinity up to 1 with parentheses. Okay, so let's talk about graphing logarithms. And just like with exponentials, we do have two cases. The first case is when a is greater than 1, and our second case will be when a is between 0 and 1. The easiest way to do this is to create a table of values for the exponential and then use your properties of inverses to get the graph of a logarithm. So let's just start off by figuring to graph log base 2 of x. And we're going to complete the table of values for y equal 2 to the x power. We did this chart exactly in section 3.1. Okay, so filling this out, 2 to the 0 power is 1, 2 to the first power is 2, this is 4, this is 8, this will be 1/2, this is 1/4, and this is 1/8. Okay, so to graph the exponential, I have my x value, my y value, create ordered pairs, and get it done. Now, since these are inverses, if you want the points that are on the log instead of the exponential, you simply switch your x's and y's. So I'm going to plot these points. 1/8, -3, 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. So estimating these, 1/8, -3, 1/4, -2, 1/2 here is getting really hard to do, but you get the idea, it's getting close right here. And then 1, 0, 2, 1, 4, 2, and 8, 3. We end up with a graph that looks like this. Okay? And our exponential had a horizontal asymptote of our x-axis. And in the spirit of switching your x's and your y's, the logarithmic function is going to have a vertical asymptote on the y-axis. Okay. Now let's do the same thing for our second case, where we have our base between 0 and 1. And I'm going to do the same thing here that I did on the previous. And again, this is a chart we also filled out in the previous section. 1/2 to the 0 power is 1. This will be 1/2. This will be 1/4 and 1/8. This is 2, this is 4, and this is 8. So if I wanted to graph the exponential, I'd do x and then y. Since I want to graph the logarithm, I'm going to do y and then x. So I will plot 8, -3, 4, -2, 2, -1, 1, 0, 1/2, 1, 1/4, 2, and 1/8, 3. okay? So 8, -3, 4, -2, 2, -1, 1, 0, 1/2, 1, and then here, and then here. And our y-axis is still an asymptote. But it looks more like this. Okay? Now, in summary, if this is comparison of exponentials and your logarithms. For an exponential, your domain is negative infinity to positive infinity. So over here, your range is the same. Here, your range is 0 to infinity. So this is your domain over here. Your y-intercept is 1 for an exponential. And if there is no x-intercept, and here they are reversed as well. Your x-intercept is 1, and there is no y-intercept. We talked about how the exponential has a horizontal asymptote at the x-axis, and your logarithm has a vertical asymptote at the y-axis. Okay, both of these are 1-to-1. So here we've used this property already. If you have the same base here and here, you can set the exponents equal. Here, if you have the same base here and here, you can set your arguments equal. This is the only part that is the same on both sides. If your a value is 1, you're increasing. And if your a value is between 0 and 1, your graph will be decreasing.